All right, so last year in grade 10 science, you learned a little bit of chemistry. It was a great introduction where we talked about the nomenclature, which is ways that we name and write formulas for compounds. So let's do a little review before we jump into grade 11 chemistry, because you'll see that what you learned last year is going to be built on today and moving forward in this unit. So, last year we talked about two different types of compounds. We have ionic compounds and we have molecular compounds. This year you'll hear that molecular compounds are also called covalent compounds. Molecular and covalent means basically the same thing. Later on, you'll learn a little bit more about why we use covalent or when we use molecular. So, if we compare ionic and molecular compounds, let's take a look. For ionic compounds, you will have a metal and a nonmetal reacting together to form your ionic compound. For a molecular or covalent compound, you will have two nonmetals. The big difference is that ionic compounds will transfer electrons, which later on we'll talk about ionic bonding. And this is where we often refer to each element having a charge. We've talked about crisscrossing and dropping those charges, which we'll cover a little bit later. Okay, so an example of this is magnesium chloride. How do I know that this is an ionic compound? Well, if I take a look at my periodic table, my metals are on this hand side, colored in blue, and then my nonmetals are over here. But also don't forget about hydrogen. Hydrogen is a non-metal. Okay, so if I have MgCl2, I can look at my periodic table. I can find magnesium right here, which is my metal, and then chlorine right over here, which is my non-metal. So that should indicate that I have an ionic compound. So we used to draw Bohr-Rutherford diagrams. This year you'll learn about Lewis diagrams. So if we just take a look at how many valence electrons or outermost electrons magnesium has two valence electrons. Okay, if you remember from last year, we wrote out the charges for each column. The first column is 1 plus, second column is 2 plus, third column is 3 plus, 4 plus or minus, 3 minus, 2 minus, and 1 minus. This will help you remember what the charges are on your periodic table. Remember that noble gases will have no charge, and that is because they have a full outer shell and they are stable, so non-reactive. Okay, so going back to our example for MgCl2, magnesium will have two valence electrons, and chlorine will have seven valence electrons. How do I know that chlorine has seven valence electrons? Well, you can use your periodic table to count from the left-hand side to the right-hand side. First column will have one valence electron, second column, two valence electrons, third column, 3, 4, 5, 6, 7. So the halogens will have 7 valence electrons. So when I have my magnesium and my chlorine, and I have to transfer electrons, you're going to take a look and decide which element is your cation, which will have a positive charge, and which will be your anion. Anions have a negative charge. Okay, so is it easier for magnesium to gain electrons, or is it easier for magnesium to lose electrons? In our case, magnesium, it's easier for it to lose an electron and give it to chlorine. Chlorine will happily accept this transferred electron. However, you notice that magnesium has a second valence electron that needs somewhere to go. So this is why we need another chlorine to accept this transfer of electrons, to accept the second valence electron. Because magnesium transferred its electrons and gave away its electrons, we say that the magnesium ion is our cation. Okay, remember that cats are positive, and that should remind you that cations are positive. They lose electrons. Now, chlorine is our anion. You can think of the word onion. It makes you cry, so it's negative. Okay, or the word an, it starts with an, like anti, so it's negative. Okay, so anions will gain electrons, and chlorine in our case is our anion. So then we're going to talk a bit later about how to write their formula and also how to name. Okay, now let's talk a little bit about molecular or covalent compounds. That is two nonmetals sharing electrons. So when you look at your periodic table, you'll find all of your if you need to identify a molecular covalent compound, all of the elements present will be over here or this hydrogen. Again, don't forget hydrogen is a nonmetal. So here's an example of CH4, commonly known as methane. So carbon will have 4 valence electrons, and hydrogen will have 1 valence electron. So the reason we have 4 hydrogens is because carbon needs to make 4 bonds. Because we are sharing electrons, each electron needs a pair. These are the electrons that are going to share. Okay? And we'll talk a little bit more about naming later on. Okay, so really important to remember that ionic compounds will transfer electrons, so you're going to have a charge, whereas molecular or covalent compounds will share electrons. Okay, so there's no charge present. All right, so let's first focus on ionic compounds. Ionic compounds can be formed in a few different ways. We are going to talk about simple binary ionic compounds, multivalent binary ionic compounds, and polyatomic ionic compounds. So first up, we have simple binary ionic compounds. When you are naming, you place the metal first. The name is as it appears on the periodic table. So for example, I would like to choose a metal. Let's say I choose potassium. So I'm going to write potassium. And that I get from my periodic table. The nonmetal goes second. So you are going to make sure you're going to name it with the ending "ide." So let's say I want chlorine to be my nonmetal. Instead of chlorine, I write chloride. And that is how you name simple binary ionic compounds. When you're writing your formula, first write down both elements that are listed. So for potassium chloride, I have potassium, which is K. The charge is 1 plus. And then I have chlorine. Chlorine is Cl on the periodic table, the charge of 1 minus. Once you find the charges for when they look like a noble gas, meaning how many electrons will it have to lose or gain to resemble to have a full outer shell and to resemble the nearest noble gas, you are going to cross and drop your charges. So in this case, when I crisscross my charge of 1 plus and 1 minus, I simply get the formula KCl. Now let's make it a little more complicated. Let's say I choose sodium, which is Na+, and I choose oxygen, which oxygen has a charge of 2 minus. Now, if I crisscross these charges, you're going to see that I get sodium 2 oxide. And that means that I need two sodiums for every 1 oxide. Okay? Something to keep in mind, sometimes you might have to simplify. So if you have a common factor between your charges, you can simplify it. So the next type of ionic compound is a multivalent binary ionic compound. So, where did it go? It carried over. So here's a list of a couple of multivalent metals. Most commonly, we're going to see iron, you're going to see copper, you're going to see cobalt, tin. Let's write that out. Cobalt, copper, Pb is lead, and Au is gold. Okay, there are more multivalent metals, however, those are the most common. What you notice for these multivalent metals is they are the same element, but they have 2 different charges. So for example, iron can have a charge of 3 plus or 2 plus. So we have to know how do we write this to when we're naming. So how can we differentiate between iron 3 plus and iron 2 plus? So let's take a look at the steps. Remember that transition metals usually will have more than one charge listed on the periodic tables. which means they can lose different numbers of electrons. So in order to differentiate, you need to use a Roman numeral to indicate the charge. So here are the most commonly used Roman numerals, and we write them in brackets between our metal and our non-metal when we're naming. Let's go through the steps. For naming, first use the same steps as previously learned for simple ionic compounds. So then you're going to use Roman numerals indicating the charges of the multivalent metal. Include the Roman numeral in that name. So if I have copper chloride, copper chloride actually, because we know copper is one of our transition metals, we need to indicate the Roman numeral, because if we take a look at the formula given, if we uncrisscross our charges, that tells us that copper has a charge of 2 plus, chlorine has a charge of 1 minus. Well, for us in our name, we need to be able to differentiate what copper is it. So you have to write copper, bracket, Roman numeral 2, chloride. Okay? That tells us that it's copper 2 and not copper 1. So if you see right here, those are the two different charges of copper. Okay? So then, when we are looking at some other examples, let's look at lead. So you need to use a Roman numeral in the name to help determine the chemical formula. Let's take a look at PbO2 versus PbO. So PbO2, if we uncross the charges, this tells us that lead has a charge of 2 plus. Okay, maybe. Oxygen, though, in this case, according to this chemical formula, is telling us that it has a charge of 1 minus. That is wrong. If you look at your periodic table, oxygen always has a charge of 2 minus. Okay, so that means this chemical formula was simplified. So what could it have been simplified from? Well, if we need oxygen to have a charge of 2, that means lead will have a charge of 4. So this was simplified from PbO4, but you need that 2. So it's Pb2O4. Okay? And does that make sense? Well, yes. If we have Pb4 plus and oxygen has a charge of 2 minus, when we crisscross those charges, we get Pb2O4. Okay? So you need to be very careful with how you name it. If you notice that it was simplified, the Roman numeral going in the middle has to be the one that was used for the metal. So lead 4 oxide is Pb2O4 or just PbO2 when it's simplified. Let's compare this to the chemical formula PbO. How do we know that it's lead 2 oxide? Well, in this case, just simply looking at this formula, and if I uncross the charges, it's saying that's Pb1 plus O1 minus. Well, that's wrong, okay? You know that oxygen has to have a charge of 2 minus, meaning lead in this case has to have a charge of 2 plus. So again, this was simplified. So watch out for this as you're going through your nomenclature practice. Okay, so this becomes lead 2 oxide. Something else to note, usually we will always write the name using lowercase letters. Okay, never capitals. So this L should be a lowercase and this L should be a lowercase. Sometimes the computer autocorrects it for us. Okay, always use lowercase letters to name. Okay, that's something you need to remember. Put a big star. So let's continue talking about polyatomic ions. Okay, recall from grade 10, a polyatomic ion. The term polyatomic means there are multiple atoms connected to each other. The different characteristics of a polyatomic ion are that they travel together in a group and they have a charge. Okay? In a formula, we'll show polyatomics traveling as a group by placing brackets around the ion. Okay, very important. Most of them will act as anions, but one group acts as cations, meaning it is positively charged. Okay, so we'll see a couple of those examples. So most of them will be anions, negatively charged. So if we look at this table, okay, last year you learned all the polyatomics ending in 8, such as carbonate has a charge of 2 minus. You learned about phosphate, charge of 3 minus. You learned about hydroxide, charge of it's OH minus with charges 1 minus. You learned about sulfate, SO4 2 minus. You learned about nitrate, NO3 minus, and you learned about chlorate, ClO3 minus. So last year, those were the most common polyatomic ions you learned. This year, you need to have them memorized. Okay, so a trick to remember them I will go over shortly. But something I want to point out, we do have an exception that we do have some polyatomics that act as cations. And this one you learned last year. An ammonium ion, NH4 plus with a charge of 1 plus, is a cation. Okay, whereas all the other ones we covered last year were anions. Okay, so again, you do need to memorize all of your eights, and we'll show you some tricks of how to remember some of the newer polyatomics. Okay, so for those of you interested in finding a clever way to remember your polyatomics, if you remember the phrase, Nick the camel ate a clam for supper in Phoenix, the underlined letter represents the symbol of the element. The consonants represent the number of oxygens present with the symbol. The vowel represents the number of negative charges followed. So if I take the word Nick, okay, the underlined letter is the symbol of the element. So N is underlined, meaning it is nitrogen. Okay, so that means it's going to be possibly a nitrate. Well, let's see. The consonants represent the number of oxygens present. So I have 1 consonant, 2 consonant, 3 consonants, N, C, and K, meaning that I have 3 oxygens. Okay? Now the vowel in that word represents the number of negative charges that follow. So what is the charge of NO3? So in this case, Nick, the I is the vowel. So in this case, our charge is -1, right? There's only one vowel there. And that's how you can use this phrase to remember some of your common polyatomics that end with 8. Okay? All right, so let's talk a little bit about how to write the formulas and how to name these compounds because it does get a little bit tricky. The first step is always to recognize, when do you have a polyatomic ion? Well, remember that polyatomic ions are a group of ions. So if you don't see a simple metal and nonmetal, so 2 elements together, you see 3 elements together, that can indicate potentially that you have a polyatomic ion present in the ionic compound. For the first little while in grade 11 chemistry, you will use the polyatomics table. Eventually, you'll have to have it memorized. So when you're writing formulas, first remember the polyatomic ion travels as a group and have a charge. You need to use brackets to show a subscript that applies to the entire polyatomic ion. The crisscross method doesn't change. You only add the step of putting the polyatomics in brackets. So if I want to make let's take carbonate. I want to have carbonate, and let's see what, we'll use the cation sodium. Okay, so if I know that sodium has a charge of 1 plus, carbonate is CO3 2 minus. Okay, let's see, how do I write my formula? Well, I crisscross and drop my charges, and I get Na2CO3. Pretty straightforward. Let's try something a little bit more challenging. Let's say now I want to have let's do magnesium, the charge of 2 plus, and let's take phosphate. If we look at our table, phosphate is PO4 3 minus. So if I have phosphate PO4 3 minus, and I crisscross my charges, I end up getting Mg3 PO4 2. Well, this kind of looks a little bit messy. And right now, if I don't have my brackets in place, it says that I have 3 magnesiums, 1 phosphorus, and 42 oxygens, which is incorrect. So this is why it's super important to put your brackets around your polyatomic ion. So we end up getting Mg3 bracket PO4 2. So brackets are very important. Also, always check, can you simplify your subscripts, okay? If you can, because they have a common factor, then do so, okay? As a quick reminder, right, if you have your element, if you have, let's say, a charge up here, right, we call that a superscript. And if we have something down here, we call that a subscript. It's a little bit of terminology. Okay, and then eventually when you get to balancing, if you have some sort of, I don't know, number here, let's put a 3, we call that a coefficient. But we'll cover that later. That's just a little aside. All right, so last but not least, how do we name compounds with polyatomic ions? Again, we're still talking about ionic compounds. When you are naming polyatomics, place the name of the cation first, then the anion. Usually the anion is a polyatomic ion. There is one exception to this rule, which is ammonium, NH4+. That is a cation. Then use the name of a polyatomic ion. Exception, if the second term is nonmetal, change the ending to "ide." Use the charge of the bottom of your periodic table if you need to double check the name of your polyatomic ion. Again, this was something you did last year. This year, you need to have them memorized. Okay, that's from grade 10. If you still have your old periodic table, you can look up the most common charges, but again, you do need to memorize your 8s, your polyatomics that end in 8. Okay, so memorize polyatomics for grade 11. Okay, so let's take a look at the example and then we'll also take a look at the exception. So let's say I have something like, I don't know, let's do KNO3. How do I name this? Well, K is potassium and NO3 is nitrate. And I'm done. Okay, because I recognize that NO3 is a polyatomic. Again, notice it ends in 8. Now let's take a look at our one exception. Let's say I have NH4Cl. Okay, you should be able to recognize that NH4 is ammonium. So ammonium is your polyatomic that acts as a cation. So that's the first word you write. That's the first thing you name. And you see that in the order you read NH4Cl, it comes first. So it is ammonia. Then, continuing with the exception, your second term that is a nonmetal, Cl, which is chlorine, you have to change the ending to ide, right? Because that's a regular element. All right? So all of those 3 different types, different forms of naming and writing formulas are ionic compounds. Remember, at the very beginning of this review, we talked about 2 different types of compounds. We talked about ionic and we talked about molecular. So far, we've covered ionic. There are 3 types, A, B, and C. Simple binary, multivalent, and polyatomic. Now we're going to talk quickly about molecular naming. All right, so when you are naming your molecular or covalent compounds, remember they are only made of nonmetals. There are no metals present, okay? Because they're only nonmetals, they are sharing electrons. Okay, and you're going to find them on the right-hand side closer to the noble gases on your periodic table, except for hydrogen. Remember, hydrogen is a nonmetal. A lot of people forget. Okay, and because of this, there's a different way to name molecular compounds. You need to use your prefixes. Okay, so when you're using your prefixes, you have mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. In grade 10, you had them given to you. This year, you need to memorize them. Okay, mono is 1, di is 2, tri 3, tetra 4, penta 5, hexa 6, hepta 7, octa 8, nona 9, deca 10. The prefix mono is only used for the second element, not the first. So you always remove, if you only have one of the first element, you do not write mono before the first element, only before the second one. So BF3 is boron trifluoride, not monoboron trifluoride. Okay, so again, not mono, but you just say boron for your first element. If you see an AO or an OO beside each other, change it to just a simple O. So when you're naming, write the name of the first element, write the name of the second element, and change the ending to "ide." Use prefixes to show how many of each atom there are. Again, do not add mono to the first atom, and if there's AO or OO beside each other, change it to just an O. So here's an example. Let's say we have CO2. Well, this is commonly known as carbon dioxide. Let's break it down now that we understand how to name, right? Where does di come from? Well, di comes from that 2. That 2 tells me I have 2 oxygens. So again, for molecular compounds, that prefix needs to be attached to the element. There's no crisscrossing ever for molecular compounds, okay? And carbon has there's 1 carbon. We don't write mono before it, okay? There's 1 of them. We just don't write the 1 in the formula. Let's take a look at another example. Let's say I have CH4. I would call that carbon tetrahydrite. Okay? Again, not hydroxide. Hydroxide is a polyatomic. Be careful. It is a hydride from hydrogen. That 4 is the tetra because there's 4 hydrogens. Now, for writing your formula, write the symbol of the first element first, write the symbol of the second element, and use prefixes to determine the subscripts, which tell us how many of each atom there are. Okay? So, again, there's no such thing as crisscrossing in molecular compounds. So, it is only for ionic compounds. Here, you're using prefixes. So, if I have something like tetrasulfur, decoxide. Again, this is just, I'm making it up. How do I know how many to write? Well, tetra is telling me I have 4 sulfurs. Okay? Whereas deca, again, I had an A and O beside each other. I had to switch it to an O. Deca is 10. It's telling me that there are 10 oxygens. So this formula is S4O10. Okay? Again, no crisscrossing, no charges. You're just looking at your prefixes. And that is a quick summary of how to name and write formulas, or what we call nomenclature, for your chemical compounds. Make sure you do lots of practice on this. The better you get, the easier balancing will be for you, and you will see we're going to use it almost every single day in chemistry in grade 11. I hope this was helpful. Please come to Extra Help if you're finding any of this challenging, and always make sure to check your answers after you do a couple of practice questions, because you want to make sure what you're practicing you're doing correctly. Thank you, and I will see you all in class soon.